Okay, thanks Will, and thanks everyone for coming along today to hear about automated testing. So just get a sense of who I've got in the room. Has anyone here written a unit test before? Oh, a few, that's good. Anyone written an integration test before? A few less. What about an end-to-end test? Handful, cool. Anyone here developed their own plugin? Or maybe a custom theme? Yeah, a few for all of these things, that's good. So a bit of background other than what Will has said, so what sort of brought me to this point where I'm going to tell you about how testing is now helping me with my WordPress work. So as Will mentioned, I worked for about 10 years in agencies, primarily as a developer, did a bit of design as well, a bit of the back end, the front end, where we wrote a lot of code. We did not write a single test. For the last 4 years, I've been working in enterprise web application development. So we write a lot of code and we write a lot of tests because it's just impossible for everyone who works on applications of that scale to understand all their intricacies and what we might break when we change them. So we use testing for that quite a lot. And I've been freelancing across design, dev and maintenance for about 15 years now. And so I do a bit of everything, which nowadays sometimes I write tests, other times I wish I wrote some tests. And my other sort of side thing is I've also done some work as a teacher, so I'm also happy to talk your ear off about that. So brief overview of what we're going to look at today. We're going to have a rapid fire introduction to the different types of testing. A fair few of you already know what they are, but for those who don't, and then we're going to dive into a case study and look at a bit of a cross-section of those types of testing, looking at three different types of testing and how we might use them to test the same feature. Then just a few things that that warrant a mention but didn't fit into that, and then some resources to share at the end. So to start off with, I want to get across what the main benefits that you will see if you put some testing into your dev process. So I'm not here to sell you on how to sell this to your clients. It's all part of your dev workflow. So three things. Number one, increasing development efficiency and accuracy. Number two, guarding against regressions, bugs and unintended effects of changes. So you've written some code, the test passed, cool, now you've got to change it, does the test. And providing plain language dev documentation. So those things might sound kind of dev language and plain English, but you'll see some examples in a moment. So that when if you're in a team, then you've got a list of requirements of what this code is supposed to do. If you come back to a site a year after working on it going, what did I write? What is this meant to do? The tests actually act as documentation as to what is supposed to happen. And that can be really helpful as well, especially for longer term projects, team-based projects. If you're in a team who implements any kind of testing and then someone joins the team, it can help them get an understanding of what the code is supposed to do. So when you look into testing broadly speaking, you'll find a few variations of the concept of a testing pyramid. It usually has 3 or more testing types that build upon each other, with the fastest and smallest ones at the bottom. And as you move up, they get more complex, they usually get slower. A common version of it is just unit integration and end-to-end. This is my little twist on it. I sort of thought this morning that I should probably put component as like a wedge that goes across integration and unit, but you get the idea. Specific to CMS driven sites. So I've added this component level, which we won't get to go into in a lot today. It's not an original idea, but it's also not super commonly shown. I'm referring specifically to UI components there, so things like blocks and template parts, testing those in isolation. And I also just wanted to specifically note VR testing, which is visual regression, which doesn't really belong as its own wedge because it sort of depends what you're doing with it, but I wanted to make a note of those. And just like the sizes of the wedges are a little bit different than you might see, just because of the realities of working with WordPress, like it might be more practical to do more end-to-end testing because you might be using third-party plugins and all of this stuff that you do just need to test the whole site. And we'll see a little bit more on that later. And it's often more practical than breaking stuff up into like isolated integration tests. Cool, so just some really quick fire definitions for those who don't know what all these types of testing are, and then we'll dive into some examples so they can actually start making a bit more sense. Unit testing basically means testing things right down at the function level. So those functions could be ones that generate front-end output. So like if you're building your own blocks, a React component, you can write unit tests for that because a React component is just a function at the end of the day. You can inspect the HTML generated by some PHP function that does like a template part or something like that. And it can be any other function that, you know, some PHP code's running on like an action hook or a filter, which is what we're going to see today. Component testing, it's like unit testing, but it's for UI components and it's run in the browser. That's the key distinction I'm sort of making between a unit and component is unit tests are not run in the browser, component tests are run. Integration testing is a bit of a fuzzier concept just because it depends what you're integrating. So there's not like, oh, these are the tools for integration tests, because it depends what it is you're integrating. So like, for example, with WordPress, if you're creating multiple template parts or blocks and you want to test how they work like in a pattern or in a page template, then that would be a kind of integration test. But today we'll look at more of a back-end one, which is using the REST API to look at what the impact my functions have on the actual data. And so that's a different kind of integration that we would do, different type of. End-to-end, once you're looking at a whole WordPress site, testing a whole user journey, like making a purchase, like finding the product, click on the product, go through the cart, all of that. It's basically where we write code to automate away all that manual testing you're probably doing. Well, a lot of it anyway, so you're probably still going to do a little bit. And you can also like run this kind of thing on a live site to make sure that things are working as well. Like you might like have a script that goes through and make sure that, you know, an automatic update hasn't broken something or client hasn't broken something, that kind of thing. Last but not least, visual regression testing. That can happen in a few different places in their pyramid, anywhere that's in a browser basically. And basically what it is taking a screenshot and comparing it to the last screenshot and did anything visually change. So it's great for stuff like modifying CSS. So say on a site that you inherited or you haven't worked on it for ages, and you don't necessarily know everywhere that like a template part is used, you can have it actually go through and take a screenshot and see if if any changes are what you expect them to be. And so similar to the end-to-end, you could run those on a live site as well. Just, hey, just take a screenshot, tell me if something's changed, you know, like has the client added 7 new menu items and now it overflows when it's on a tablet and that sort of kind of thing. You could potentially do that as well. So to actually get started with writing some tests, what do you actually need? At the very base level, you're going to need some sort of IDE called code editor. We're going to be writing code. Even if you're looking to test like combinations of themes and plugins, you're not writing your own code. Writing your test, you're still going to need to write some code. So if you were testing plugin or theme code written in PHP, then you'll need PHP and Composer available on the command line. So you can install and run those tools. And if you're going to be doing so with JavaScript, then you'll need Node installed and available on your command line. There will be some more tools you'll need depending on the types of tests that you write, and we'll look at a few of those today. Cool, so let's get into our case study. So a bit of background on where this sort of came from, because it's not a real client one, it's sort of more of an amalgamation of common things. So at the last agency I worked at, we had a lot of e-commerce clients who we wrote our own custom like small extensions and plugins for stuff like custom pricing, different shipping methods for different user roles, different payment methods available, different prices available. And as a freelancer, I've also done some things like that as well. But some of the examples we had in that agency were a toy shop that had wholesale and retail customers. So we had an extra user role for wholesale, an extra field for the wholesale price, some logic for making sure that the customer got the right price. There was also like a minimum order for a wholesaler, and so that impacts like their checkout experience and the price. Another one was a winery. It had even more tiers than that. So you could have a membership, so you got a discount, but then there was a price break at 6 bottles of wine, so you bought a case of wine. And so then your price per bottle was different, but you had to buy them in groups of 6. So that meant stuff like, and this was before I knew anything about testing. And when I started learning about it, it's like, oh yeah, this is what we needed back then, because you had to do things like test for exactly 6, test for 7, test for 11, test for 12, because like your 7th bottle is the same price as 1 bottle. And on top of that, you had your member prices and you had sale prices. And so one product would have like 4 different prices at any one point in time, and we had to test all of that manually. I had a giant spreadsheet where I had to put it and make sure our staging site had a product that met all of each different pricing scenario. And then we had to go through manually test it as all the different kinds of user and all of that. And when we found a combination that didn't work, I had to go fix it. And then we had to test every possibly impacted scenario again, manually. It was not efficient. It's very prone to human error for missing stuff. Maybe you logged in as the wrong user or that sort of thing. So I would really not recommend it. And that's the sort of thing I want to get across to you today. So our case study today, my hobby's dancing, so we're going to run with that. But as there's sort of similar thing where we've got different user roles. So let's say they sell leotards, tights, shoes to 2 key customer groups, individuals and dance schools. But dance schools can get special pricing on a bulk order. Individuals can sign up for a membership. They get some special pricing. On the technical side, so that means we've got, within WooCommerce, we've got regular and sale price built in. But then we need an individual member price custom field and we need a bulk price field. It needs to support simple and variable products, and the variable products will all have, all the variations will have the same price. School price kicks in at the category level, and the key part is, because we won't see all of this functionality in the time we've got today, and also I haven't finished building it because it is a demo. Customers should always get the lowest price per item that they're eligible for. So things like if something goes on sale for less than the member price, the member should get the sale price. If the member price is cheaper than the sale price, they should get the member price, and so on. So the way I start with that is our unit test, our foundation. We start from the bottom up. And so we need to translate those requirements I've just described into test cases. And some examples of how we might sort of phrase that is, and there's a lot more than this obviously, it's just to give you an idea, is things like if the member price is lower than the sale price, members should get the member price, non-members should get the sale price. If there's no sale price, this is what should happen. But if we have an edge case, like the member price is accidentally set higher than regular, like the admins are not infallible, if I don't have any back-end validation for that, like WooCommerce doesn't allow you to set a sale price that's higher than regular, but my code doesn't have that, it's just a custom field. Also need to test, like, what if they're exactly the same? What happens if something goes on sale to the member price? What happens? So some of the tools we might use for that, I'm using a library called pesky, which uses one called PHP unit under the hood. You might have come across that one, those of you who have written unit tests. And pesky actually uses PHP unit under the hood. It just provides a different way of writing things and more utilities. If I was doing something similar with JavaScript, there's Jest and there's VTest, there's others as well, just to give you some idea. And yeah, so this brings me to another key concept of the day, is test-driven development. So what that means, basically, and it's considered somewhat of a best practice, it's not always practical, especially to do 100% test-driven, but it's a good idea it's a good thing to sort of know about, is that you can write a list of requirements as tests before you've even written the code, or alongside the code, and then you progressively write tests for, like, write the code for a part of the feature, run the test, make it pass, write the next bit, make sure what you wrote earlier is still passing, that you haven't broken your earlier work with your new work. So you write tests that you know will fail, and then you gradually make them work. So here's an example, it might be a little bit tiny, but all this code is available on GitHub that I'll share at the end. So building out the member price functionality is what we're going to mainly look at testing today. So then we've got that baseline before we start adding the bulk pricing, and then build up from there. It will help us guard against, those regressions, and it provides us some documentation for our future selves or other devs who might work on the site. It's a quick look of how that looks in my editor. Once I've written some tests, I can go through each one, see which one's failing, go and test it, and then run it again. And it also shows, if you can see there, just how fast these run. So these ones ran at 195 milliseconds. I actually got them running faster later, but that could be I ran this on my desktop. This laptop is faster. But that brings me to another key concept I just want to note super quick. Is one of the principles you might come across when you're looking at testing is the first principles, which is just a goal that when you write your tests that you want them to sort of meet these criteria. You want them to be fast. You want them to be as isolated as possible so they just test the thing you're setting out to test and not interfered with by other stuff. Like, 'cause the point is we test this, it works, we test this, it works, we test this, it works, then we put it together and make sure it still works. And then if something's not working, it helps us find out which piece of the puzzle is not working. Repeatable, so things like if you're testing with a date, you should have a set date. You know, it should be able to be repeated all the time and not have sort of things thrown in that could throw it off. So it's like, given this scenario, this is what happens. Self-validating, so it should just tell you if it passes or not, basically. And timely, so ideally you want to be writing tests at the most useful point in development for yourselves as part of the process. Sometimes that doesn't happen, so like I've gone back to some of the plugins I wrote years ago and I'm still using and going, well, I'm going to add tests to them now because then next time I discover a little bug, I'm going to have all this there. But now if I build anything new, I try to do any testing that I think I'll benefit from alongside writing the code so that I get all these benefits of being able to run it as I'm building. Okay, so here's an actual test code. So this is one for handling the sale prices. So we want the products not to show as on sale when the member price is cheaper. So we need to set the sale price to empty. And so this is, a bit of an overview of what the test case looks like. Just a very quick look at what the actual code looks like. Again, this will be on GitHub. So I feel like I need to maybe speed past this to get some of the other stuff. But the general thing to notice here, we've got a class called item pricing. And inside that are the methods or functions that are run on action hooks and filters to do stuff to the price. For example, update the sale price. And then, so how we test that, coming back to that, at the top of each test case, we've got our 3 prices that we care about. We're setting up the scenario. Given this situation, where the regular price is 25, the sale is 20, and the member price is $17.50, now I'm going to test that scenario. I'm going to instantiate that item pricing class so we can actually run stuff. But then we've got these things called mocks in there as well. And so what that is because I don't have a real WordPress site. I don't have database. I don't have users. I'm just testing the function. So I need to tell it that this is the scenario where it's a member and this is where it gets that from and this is where it gets those pricing fields from. And so we use a concept called mocking and stubbing for that, so that when your function that you're testing, so you call your real function, but the ones that happen inside it, you give it a predefined response. With these test double type concepts, there's a whole lot of them. It gets a bit confusing. It's like, is this a mock or a spy? And like, there is a difference. But ultimately, it's test doubles. We're giving it predefined responses to those function calls with some sort of replacement version. Sometimes we can even go, hey, was that called or not called? But the key thing is to know, you're doing a predefined response. So here's an example of that. Because I don't like to repeat myself, I put them all in a mock utility file, but you could just dump this straight into your test as well. And so I'm using a library here called WP mock. There's another one called Brain Monkey that I like as well. They're pretty much the same thing. I actually did a whole write-up on trying to compare them and concluded they're pretty much the same things in my experience so far, where basically we tell it when the current user can function gets called with this argument, so in this case, member, then return this. And so this is like a wrapper function I've done to go, hey, mock the user role or capability, member, with true or false. And then so we use WP mock to be like, hey, when this is called, then just return this. And so it doesn't actually call WordPress. WordPress isn't in here. You could be doing this without WordPress on your machine. And then, so you use that to set up your scenario and go and then call your function and it will know that. Similarly, we don't have actual WooCommerce, so we need to mock a product object. And so we do that with a library called Mockery. which WP Mock and Brain Monkey both use under the hood and install as part of their installation, so it's not an extra dependency. So we just set up the parts of a product that are relevant to what we're doing. So we go, and so Mockery has, you can tell it, hey, this is a WC product, and then it knows to act as a WC product, and yeah, what methods you expect to call, like get regular price, and so on. Yeah, so we come back to our test case, and so we mock the product with just the bits we need, and that's just replacing my utility with what is in the real test. Then we tell it to mock get post matter, so that those calls to get those custom prices, here's what they would be in this case. Then we check when it checks the user role, this is what we expect you to do. And then we call our actual function that we're testing, we don't mock that one. And then finally we assert what we expect the result to be. In this case, given all of this, run this, and then we expect it to be empty. Which brings me to my next concept of the day, just shoehorning in these theory bits for you very quickly, is the AAA test pattern. So arrange, act, assert, also known as given, when, and then. So it's just a way of structuring your test case so it's nice and clear the steps that are happening. So this is the same test case again, just with different comments on it. So first we arrange the scenario that we're testing. So we go, hey, these are the numbers that I want to pop in. Here are the results of those functions that get called inside it. And then I act. So this is given this situation, when or I do this action. So when I call update sale price, then I assert this is what happened, or this is the result. You might see some slight variations on this, like you might have like 2 acts and asserts, or you might have an assert before an act so that you make sure, which we'll see in a moment, just to make sure that like your action actually changes something or something like that. But if you're doing a lot more than that, that's probably a sign that you should actually break it down into more tests to just make sure you're testing one thing at a time. Cool. So we've given it fake functions. We've gone, yep, if this function gets called, this is the result. But then you're probably wondering, but what about the real functions? And what about the real data? And what about when I combine them together, especially in WordPress? So let's fast forward a little bit. We've assumed we've also done our bulk pricing. We've unit tested those, but we're not done because those are just the individual units. And this is WordPress and WooCommerce. There could be other plugins, other random functions thrown into functions.php that run on the same hooks and mess with your functionality. Your own code could be calling, the action hooks or filters in the wrong order. And then so while your individual units work, when you put them together, something's wrong. And so that's, those units will help you go, well, the individual functions are calculating right. And so now you already narrowed down that it's probably something to do with when they're called, things like that. But so ultimately to get to that point, we need to also test it in a real site with real WordPress or real data to some extent at least. So a very, very quick look. Integration testing is one of the ways we can do that. As I sort of touched on earlier, integration test is a bit of a fuzzy term because it depends what you're integrating. And I've only given it a small slice of my personal pyramid just because it's very hard and probably not worth the effort for a lot of things to like somehow just get the piece of WordPress that you need or the plugin that you need in your thing. But then I thought for this one, I actually have a really good idea of how I could integration test this, and that's with the REST API. Because then I can go, well, what is the end result at the pure sort of data level? What data is getting stored after my functions are run? And so, yeah, just a super quick one because just for time. Yeah, the code of this will be available. And so I was able to reuse a lot of my unit test code and the same test cases, the same tooling. So this is all PEST as well. Just instead of mocks, it calls a REST API. And so I had to set up a bunch of products that met the criteria. And so that's why I have got extra assertions in there so that if anyone messes with my test data, my test will then fail. because you could easily get a lot of false positives if, by coincidence, the data, would meet a test case that isn't actually right, or a false negative as well, where it's like, oh, and then this fails. It's like, that's because that doesn't actually meet the criteria. But it's a lot of the same stuff. It was very sort of straightforward to translate from my unit test into an integration test. And that's when I actually started to find some bugs things where it's like, oh, I actually need to add another filter hook there, and because there's some other function that's being run that's impacting this. And then the third type of testing we'll look at today is like, but what about the whole website? So for the integration test, I just had just WooCommerce and just my plugin installed. I could also do it with other plugins installed. And for my end-to-end, I haven't installed anything else as well. But the idea is that your end-to-end has your client's real theme and all the real plugins that they're using. So you're still going to probably do it on a dev site, staging site, especially if their real data doesn't actually meet every possible case. You'll need to add some extra examples so that if in the future that case happens, you've already tested for it. And so then that's going to help you narrow down. Say you did do all three kinds of testing. I'm under no illusion that you probably won't. So the idea is you see all three of these and sort of pick which one or two or pieces of them would work for each of your use cases, and the ones that I don't get to talk to as well today as well. But say you've done some unit or some integration, and they all pass, so your stuff works, and then something in the site is wrong, then that means you've narrowed it down to it's probably some other plugin or maybe something in your theme that's doing that. Whereas if in the integration test, that the end value was wrong, even though the unit tests were passing, it's like, oh, something in my code is not right. So it really helps you narrow down where the problem is when you have one. So end-to-end. So what that's going to do is it's going to navigate through a real site in a real browser like a user would. And so, the main benefit is it's going to code away that tedious manual work by doing all that clicking through yourself. The downside is if something's not right, it doesn't really tell you why. You've got to... Thanks, Siri. Can you tell me why? Apparently. If you were only doing end-to-end, it doesn't really tell you why something's wrong, and that's why I would recommend combining it with at least one other kind of testing. And so some tools for that. I use Playwright. I've also used Cypress a little bit. Selenium, some of you might have used as well. Any of them, you can use these to visit the URL in a browser and interact with them like a user would. So here's a quick example of one of my Playwright tests. So for this example, it just logs in, visits the page and checks the price so that it's basically what the other tests are doing as well, so we can compare a bit. But once sort of all the functionality was there, you would also add to cart, especially with bulk pricing and stuff like that. Edit the quantities, make sure that the pricing gets updated, all of that. And so the structure and the terminology is all very similar. You've still got those expect statements for your assertions, but you're doing things like go and visit this page, find this element on the page, and things like that. And what do we expect to be present on the page? Cool. And Playwright also has a UI mode, which you might find appealing rather than all of those command line stuff. And it actually allows you to watch it. It also has a debug mode, so if something's not right, for example, I had one that was like, it kept saying the sale tag was there, and even though the REST API was telling me that product wasn't on sale for a member, what is going on? And so I went and I watched it in the UI mode, and it's like, it's not actually, the login wasn't working, so the test was viewing this as a guess. And so that's something that the test failing on its own didn't really tell me. And I had to go through and look. And so, yes, you could go and do that manually as well, obviously. But if you've got a whole lot of test cases, you automate that, go and run the test and go. If you've got heaps, go make a coffee, come back and see what failed. And so, which brings us to go get a coffee. You might be thinking to yourself that one of these is a clear winner for you. Why would I do unit tests when I could do end-to-end? Why would I do unit when I can do integration? So that's partly why I've tested the same stuff in this demo across all three so we can compare. There's definitely some things that each one can do that the others can't, or can tell you that the others can't, but they largely test the same thing. So one thing I really want to highlight, because it's all about the efficiency for yourself, is the speed. So here I have 23 unit test cases. They run in 78 milliseconds. With coverage reporting, which I'll get to very quickly in a moment because I'm already on 30 minutes, still under half a second. So you can keep constantly running those because they're very, very fast. The integration tests, testing largely the same stuff, 12 test cases in about 5 seconds. So that's still pretty fast, but by the time you add all the features, that's going to multiply. They're going to be a little bit slower than unit tests, but you might decide that the benefit of that, because there's the trade-off of fake data, real data, you might decide the benefit of that is worth it for you. Whereas the end-to-end tests, while that gives us the full picture, and so there's a big cell there that this is the full picture of the whole site, 10 very basic end-to-end tests that just log in. Some of them don't log in because they're testing like the anonymous user price. It takes them almost a minute to just either log in or not and visit the page and check what's visible in the price. And it's like, that's very slow. So you've sort of got to weigh up what benefit am I getting? Is it worth running that? And just a very, very quick hypothetical, if I haven't already sold you on this, as to what some of the key benefits are. Say your client comes back in 6 months. Now there's 2 membership tiers. What do? You've got to make sure that the pricing for the original membership tier stays correct and the new members get the right price, that you don't start accidentally giving the new members, maybe the old members get cheaper stuff, I don't know, but that everyone keeps getting the right price. And so you go back to things like these 78 millisecond unit tests, you add a bunch more for your new logic and then make sure that the old logic still works very, very quickly, rather than having to go into your site and look at each individual one again and again and again. Then yeah, you're probably still going to look at the real site, but you're going to have a lot more confidence by the time you get there, or by the time you send it to the client or internal QA, that it's probably correct. There's not going to be as much back and forth. Cool. Yeah, which brings us back to our main 3 benefits that I wanted to get across. Cool. So just a few more things I wanted to touch on. The elephants in the room, 3 things. Accessibility testing. So some of you might be wondering, if I'm getting an end-to-end test to visit my site in the browser, can it tell me if it's accessible or not? Because it's visiting the site as a machine, so it can see the accessibility tree, can it see all the alt text, the ARIA labels? So the short answer is yes. The real answer is yes, but it should be part of a broader strategy. And the reason, so most testing frameworks that can look at HTML code will have something like this, an assertions like, yeah, it's accessible, or it doesn't have accessibility violation. But that's only looking at very specific things, like HTML semantics and WK guideline conformance for stuff like HTML structure, color contrast, stuff like that. It can't cover everything, and it's not a human. And so for stuff, and also isn't probably going to tell you where it can be improved. It's going to tell you this doesn't violate any of the guidelines, but maybe you could improve it with like some ARIA attributes. There's more semantically descriptive HTML tag you could be using. It's not going to tell you that. Things like where does the focus go if you close a pop-up from a keyboard? It's not going to tell you that it should go back to the button that it came from, but you can add more tests that test for those specific things and look at things like the roles and ARIA labels. So yeah, this should be your starting point, but you should be adding your own tests for those specific things that you have. AI, everyone's favorite buzzword. I feel like it's not allowed to not mention AI in something like this. Yeah, like it's not the devil, but it's definitely something that you should use cautiously. I personally find GitHub Copilot really, really helpful for helping me write tests, because I'll write one test or write a test case and it'll give me suggestions of the next one, and just pre-filling it just saves me a whole lot of typing. And it can populate some of the other tests for me. I also started using Junie, the AI agent in PHP Storm, and was like, and I've written out like the test cases and written like 1 or 2 of the code, and I'm like, can you fill in the rest for me? And it didn't do so 100% correctly, but it still saved me a whole lot of time. And I'll also sort of, a whole lot of typing. It still took me some time. So sometimes I might ask like ChatGPT or Claude or for ways to mock something to help me populate a list of test cases, or to help me populate a list of test cases. But yeah, something just to be used really carefully and to really take the time to verify any solutions that you accept. Because if your code is wrong, it might not understand your code is wrong, and so it's going to write a passing test for code that shouldn't actually pass the test. So you've just got to be really careful about that. It will suggest things like mocking functions or functions in a plugin that do not exist. And so you've got to go and actually recognize that, or just things that maybe don't need to be mocked. So you should use it as a tool to help you, absolutely. It will help you be more efficient, which is especially for this where you're like, this is going to take me more time, and but so you can help take less time. So yeah, and not use it to help you, not replace you. Yeah, so the third of the few things is coverage reporting, which I mentioned very briefly earlier. Didn't go into a lot of detail about this because I'm being realistic. A lot of us here are like in agencies or freelance, working on client projects. So making sure every single line of code is probably not going to be a high priority, but it is a really good tool to have in your toolbox. And so what it is basically tells you how much of your code was executed during tests, and so which parts are not actually being hit by the test. So then there could be a bug in there and your test isn't going to pick it up. So it's a really helpful thing to have in your toolbox. Here's an example. You can see I haven't written all the tests for all the features because I've got a bunch of red ones. So if you're working on a plugin or something that you're going to use for a lot of projects or you're going to distribute, that's when this stuff becomes more important to make sure that you don't release a bug. And if you're in a team, you can, and you're using something like Git, you can also have these things run on like your pull requests, so people can't actually merge code that fails tests. But for that to be useful, you have to have most of your code covered. And so why that one's yellow is so as part of like doing those integration and end-to-end tests, I was like, oh, I actually have to set the is on sale field to false for those members, not just set the sale price to empty, so that they don't get that little badge. And so I had to add another method, and I haven't added tests for that. So that's coming up red. So if that, it's a pretty simple method, so I'm not too worried about it, but I did find it was a little bit iffy in some parts with just the different combinations of stuff. I probably should write a test for this, especially if it was a more complex method that did a little bit more than true or false or something. Then you're probably going to want to write a test for that particular thing and then get that bar green. It's very satisfying to get those coverage bars green. So it can help give you confidence, but it doesn't necessarily mean that that nothing's ever going to break, because if you've got like certain edge cases that code doesn't handle and you haven't tested for, it's not going to tell you that. It's just another tool to have in your toolbox. Cool. So very, very quick summary of what we looked at today, types of testing. I had a whole lot more examples and detail, and I'm already talking really fast to try and get through it all. So I've actually put this all up on a website for you. And so you can find a lot more detail on the types of testing, how to get set up, some more examples, going through that case study as well. And I will be continuing to add to that as I'm doing sort of more testing in my current projects. Some of the pages just aren't quite finished yet. I've got a whole lot of planned examples and stuff, so we'll be continuing to add to that if and that's something you're interested in looking at. If you just want to see some simple real-world examples. And I'm also open to requests. No promises, but open to some requests. To continue to summarize, we looked at 3 key benefits for you as developers and for your teams, even if you've got QA people, of benefits that you can realize from adding testing to your day-to-day workflow. So it shouldn't be like an extra step that you sell to the client. This is all part of your workflow for your efficiency, your accuracy, not introducing bugs, and documentation. We saw a few acronyms. The testing world loves its acronyms. This is just the beginning. And we also looked at a few tools, and here's a bunch more tools that you might come across. Not an exhaustive list, but yeah, just some ideas for you. And some of those are covered a bit more on that companion website as well. Thank you very much. And yeah, so that's up there. Thank you. And all the code for that case study as well is also up on my GitHub, and it's linked in various places throughout that site as well when we look at the case study. So if you can actually go and grab that code bases and run those tests yourself. Any questions? Yeah. Well, that's a great question. I find when you're first learning to write tests, it can take up a lot of time, and I think that's why a lot of people give up, because if you're very short on time, and because it can, like some of the syntax and the way sort of mocks work, it can be really overwhelming and confusing at first. But once you get the hang of it and it becomes part like a habit, it doesn't take up a great proportion of time, I find. I wouldn't say definitely less than 50-50. But yeah, I've not really measured it, but it does add some time. But you then saving time later because yeah, you're not having as much back and forth with bugs. Clients found something's not quite right, or someone in your team's found something. So you sort of get that time back. So it is hard to measure, and but yeah, you sort of get a sense after you've done a few projects with some tests and what type of test and where it's worth investing. Honestly, no, not really. It's more just like more of a sort of a risk way up of how sort of fragile do I feel like this code is. Does it have a lot of edge cases? Does it have a lot of different scenarios that it's going to save me time to automate it? Or are these things that I'm worried might break, and so I'm testing them and retesting them all the time, that maybe I could automate that. And yeah, so what's the likelihood of something going wrong here? And so it's the more sort of actions and filters and the more moving parts I have, yeah, the more time I'm inclined to invest in testing, because yeah, it's going to stop. Yeah, visual regression. So you can use Playwright for that. That's one of the few things I haven't yet put an example on that website, so that's number one priority, put an example of a VR test. Is so like you can take a screenshot of the whole page, you can take one of just, you might just put one of your template parts on a page, which is one thing I've sort of set that up for this, but not actually done the test. And so you, in your Playwright test, can actually go, hey, go visit this web page in the browser and take a screenshot, and it will literally save a PNG of that page. And then when you next run the test after you made some changes, it will actually tell you if a certain percentage of the pixels of those screenshots are different.